So AI is getting incredibly smart, right? But here's the bigger question. Is it getting wise? We're stepping into a new era where AI isn't just a chatbot, it's an agent. It's starting to run our infrastructure, manage our money, and make real-world decisions. And that, well, that opens up a huge can of worms. How do we make sure those decisions are safe? How can we audit them? How do we know they're aligned with what we actually want? Today, we're going to look at a company called Xybernetex that thinks it has the answer. All right, let's get into it. In this quote right here, it just nails the problem. Imagine these super powerful AI systems making critical choices, but we have absolutely no way to see their work, no way to replay their logic, no audit trail. We're just left wondering why it did what it did. That's the scary part, and that's the challenge we're facing right now. So let's really break down this control problem. It all comes down to a massive shift in what AI is even becoming. We are smack in the middle of a major evolution. Okay, so this slide really puts it in perspective. On one side, you've got the first-gen AI. Think of it as a tool. You give it a prompt, it spits out an answer. You're in control. But now, look at the other side. That's the next generation, autonomous agents. These things don't just respond, they act. They can write and deploy their own code, manage entire systems, and carry out complex plans all on their own. And this really shows the problem visually. When AI was just a tool, things were structured. They were predictable, you knew what you were going to get. But with these new agents, it's a whole different ballgame. Their reasoning can be opaque, a total black box, which makes their actions feel completely unpredictable. And here's the bottom line. Our ability to build intelligence has just completely outrun our ability to build control. It's like we've created these incredibly powerful rocket engines, but we totally forgot to build the steering wheel, the brakes, or any kind of navigation system to guide them. That right there is the control problem. And this is exactly where Xybernetex comes in. See, they're not trying to build a bigger, better AI model. No, their focus is on something else entirely. They're building the missing piece of the puzzle, the infrastructure we need to manage all the AI we're already building. You know, if you think about it, every complex piece of tech we use has one of these control layers. We just take them for granted. The internet itself needs TCP/IP to make sure data gets to the right place. The cloud uses Kubernetes to juggle all those apps. Payments have systems like Stripe. These are the fundamental rules of the road. But autonomous AI agents, they're driving without any rules at all. And that is the gap Xybernetex wants to fill. They're building what they call decision infrastructure. It's a brand new, essential layer that sits right between an AI's intention and its action. It's there to provide the structure, the governance, and maybe most importantly, the audit trail. All right, so that's the big idea. But how does it actually work under the hood? This is where it gets really interesting, because their approach completely flips the script on how we use AI models for making decisions. Let's dig into the mechanics. Okay, so instead of just asking an AI, hey, what should I do, and just hoping it gives a good answer, the Xybernetex engine uses a technique from game theory called Monte Carlo Tree Search. The best analogy is a chess grandmaster. They don't just think one move ahead. They simulate thousands of possible games, exploring all these branching futures to see which moves lead to a checkmate. That's what's happening here, exploring thousands of paths to find the one that's the most solid. So how does it know which paths are good? This is the brilliant part. It uses a large language model, but not to make the final choice. It uses it as something called a stochastic transition function. Now, that sounds super technical, but the analogy makes it dead simple. Think of the LLM as a weather forecaster, but for decisions. You give it a scenario, and it doesn't give you one answer. It gives you a whole range of possible outcomes, and the probability of each one happening. It's the forecast our chess master needs to figure out which moves are smart and which are. And you really need to let this sink in, because it's the most important part of their whole system. The LLM gets a demotion. It's no longer the CEO making the final call. It's more like the intelligence agency, the mapmaker, the advisor. It's a powerful probability engine used to chart out all the possible futures, but something else is in the driver's seat, choosing the final path. This is a huge shift from just letting the LLM run wild. So once all those futures are mapped out, how does the system actually pick the best one? This is where it gets really clever. The system has its own built-in red team, a council of 4 different AI personas that argue it out. You've got the operator, who's all about execution, the quant, who only cares about the data, the contrarian, whose job is to poke holes in everything, and the steward, who's thinking about the long-term impact. They all challenge and score every single path to avoid any kind of AI groupthink. So let's just recap the whole process. First, the engine explores thousands of possible futures, like that chess master. Second, it uses the LLM as a forecaster to predict what's likely to happen down each path. Third, that internal red team of personas debates and challenges all the assumptions. And only then, at the very end, does the system make a final, defensible choice. And here it is, the solution to the black box problem. Every single time this process runs, it creates a permanent, auditable record they call a tick file. This file has everything: the initial problem, all the simulated paths, how each persona voted, and the final choice. It's a complete decision ledger. If anything ever goes wrong, you can replay the entire thought process just like a flight data recorder. But what we've seen so far, that's really just the foundation. The company's long-term vision is built on this really smart 3-layer strategy, where each layer builds directly on top of the last one, creating this powerful, compounding advantage over time. So Layer 1 is what's live today, a powerful API. If you're a developer building an AI agent, you can just ping their API with a complex decision and get back a structured, defensible, and totally audited answer. This is the bedrock, offering decision-making as a service. Now that foundation makes Layer 2 possible, the agent framework. The idea here is to plug their decision engine directly into the big multi-agent systems that are being built. So instead of just helping with one-off decisions, Xybernetex becomes the central control tower, the air traffic controller that governs how whole fleets of AI agents work together. And the final layer, Layer 3, is the most ambitious of all, creating what they call decision-native LLMs. This is where it all comes full circle. Remember that decision ledger with all those tick files we talked about? Well, that becomes an incredibly valuable and totally unique dataset. And this creates a brilliant data flywheel. Every single decision that gets processed by the API in Layer 1 creates a perfect piece of training data. It shows the problem, the solution, and the entire reasoning process behind it. This proprietary data is then used to train specialized AI models in Layer 3 that are purpose-built for high-stakes decision-making. It's a dataset that literally no one else can create. Which leaves us with a really powerful thought to end on. As we start handing over more and more control to autonomous systems, the big question isn't just about making AI smarter. The real question is, how do we build structured reasoning, accountability, and even wisdom into these things? Who's building the fundamental operating system for machine decisions? Well, Xybernetex is making a pretty compelling case that they are. It's a truly fascinating take on one of the single biggest challenges in tech today. If you want to dig deeper into their white papers and their whole architecture, you can check out their website. Thanks for watching.